Hey, trigonometry class. We're going to be looking at section 2.3 in this lesson today, finding trigonometric function values using a calculator. So that is what we're going to do, find function values using a calculator and also finding angle measures using a calculator. So in this section, a lot of people kind of blow this one off because, oh, we just have to use our calculator. I know how to use my calculator. The thing is about this section is, yeah, we are to use our calculator, but we need to know what we have learned in trigonometry thus far in order to help us figure out certain solutions to um, trigonometric functions using the calculator. So you have to draw on um, prior knowledge in order to use your calculator in this section. Okay, so let's get started. Okay, so I'm going to use my little handy calculator here to show you how to find these or to approximate these values that we have on this slide here. So the first two are actually pretty easy. We just plug away into the calculator. Let me do that with my mouse. Okay. So these first two, tangent and cosine, we have those trig functions in our calculator. We have sine, cosine, tangent here. So plug in tangent. Oh, let's make sure our mode is in degrees before we move forward. Every single time I use this, I have to set it in degrees because my RAM on this thing resets. And speaking of RAM resetting on your calculator, if you let your calculator's batteries die long enough, your RAM is going to reset too, which means programs are deleted and also your setting that you change here in your mode is changed back to its original settings. So, got to change it to degrees. And then we're going to put in 68 degrees and 43 minutes. Okay, so there we go. That is plugged in now. We just hit enter. And ta-da, there is the solution to the first one. So go ahead, write down that here. I can't write it down for you because I will lose my emulator here. And I'll have to open it back up for you. So the next one, let's do that. Cosine of 193.622 degrees. Now, whenever we have decimal degrees and your calculator mode is in degrees, we don't necessarily have to put this symbol here. But whenever we are given degrees, minutes, seconds, form of a degree, then we do need to go ahead and put degrees and minutes into our calculator right here. All right, so plug in cosine of 193.622. Close the parentheses and hit enter. Oh, well, let's take a look at that. Let's redo that one and see. I'm just going to compare. Let's put in degrees and see if I was wrong about that. And close our parentheses. And no, I wasn't. See, if you put in degrees or if you don't for decimal degrees, it doesn't matter what you do, whether you want to put a degree symbol in there or not. Just remember, your mode needs to be in degrees. Okay, so there is the solution for part B here, the negative 0.9718706. And for approximating these values, I'm going to go ahead and say if your book doesn't state it, approximate to about, I'm going to say 6 decimal places. I want a good approximate answer here. Okay, so 6 decimal places. All right, let's move on to the next slide. Okay, on these next two, C and D, see we are asked to find cosecant of this angle and then secant of this angle. Well, before we can go and do that, we only have sine, cosine, tangent on our calculators. We need to know that 1 over sine is the same thing as cosecant. Okay, so I'm going to go ahead right in here. I'll bring up that calculator in just a minute and say, if we were to plug in this into our calculator, which we can't because of this cosecant, we don't have that function in our calculator. What we do have to plug in is this right here, 1 over sine of our given angle, which is 35.8471 degrees. If we plug that in, then we are going to find our correct solution. Kind of same thing goes here with secant. The reciprocal of secant is cosine. So this right here is the same thing as you plug into your calculator, 1 over cosine of your given angle, which is negative 287 degrees. Okay, so let's do that. All right, so over here on my calculator screen, I'm going to clear this out. I'm going to say 1, let's do part C over here, part C divided by sine of 35.8471. 8471. And like I said, you don't have to put in the degree symbol when it's in decimal degrees as long as you have your mode in degree mode. Now enter. There is your function value for cosecant of 35.847 degrees. Okay, so write that down. And then let's do the secant now. We're going to say 1 divided by cosine of negative 287 degrees. Hit enter, and there is your value for secant of negative 287 degrees. So that is how you do finding function values using your calculator. Now let's look at finding angles using your calculator. Okay, on this one, this example, we're asked to use a calculator to find an angle theta in the interval of 0 to 90 degrees that satisfies each condition. So I'm going to show you kind of technically how we go about finding this one, and then you can use the shortcut anytime you want. So for these two problems in my examples here, it does say 0 to 90, but your book in some of your homework problems may give you a different interval. In that case, I will show you in class how to find your angle theta for a different interval for 0 to 90. But what we're about to do will always find your angle theta that is between 0 and 90 degrees. Okay, so let's go ahead and get started. What we are doing is we are solving this equation. Cosine theta is equal to, I'm going to give myself a little bit of room here, 0.9211854,056. We're solving this equation, and how we solve for theta is we take the inverse cosine of both sides of our equation. All right, so theta here, the inverse cosine of theta gives us theta. So theta is equal to cosine inverse of 0.9211854,056 And this angle is going to give us a degree. So whatever your solution is, whenever you plug this into your calculator, it's in degrees, as long as your mode is in degrees, or else it'll give you a radian measurement. Okay, before we plug that into our calculator, let's do this one, cotangent. So instead of doing this step right here, you can go straight to this one right here. Just say angle theta, it's not reference angle. Angle theta is equal to the cotangent inverse of 1.446647. All right, but here we have cotangent inverse of this. We do not have a cotangent inverse in our calculator. So what we need to do to be able to solve this one is figure out a way to use our tangent on our calculator, because the reciprocal of cotangent is tangent. So if we look at, say cotangent, sorry, that is really sloppy. Cotangent of theta is equal to 1 over tangent. Or we can pretty much interchange tangent and cotangent here. So what we're actually looking for is, this is the same thing as stating tangent of theta is approximately 1 over 1.446, that whole long decimal number. Okay, and now we do this right here. We're going to find the inverse tangent of, let's see, the tangent inverse of 1 over this decimal number. Okay, so now let's bring up our calculator. And let's figure out the solution. So do the cosine inverse. Let's figure out the solution to this. Theta is going to be equal to get cosine inverse, it's in yellow here on my calculator. So you just hit second cosine, and there's cosine inverse. And you put in your long decimal number, so 0.9211. I think that's correct. All right, and then close your parentheses, hit enter, and there you go. So we have an approximate angle measurement of 22.8999, repeating, looks like, degrees. Okay. On this one, for approximating your degrees, I'm going to say round it to the nearest hundredth, so 2 decimal places. Okay. If it doesn't state how many decimal places to round it to. All right, let's look at the cotangent one. Remember, we're going to put in our calculator tangent inverse of 1 over our value. Again, hit second, and now go to tangent. That gives you tangent inverse. 1 over 1.4466474. Close the parentheses, hit enter, and there you go. Our solution is 34.65 degrees. Let's look at some more. All right, on this example, this is just our setup for what questions we are about to be asked. So when we have an automobile traveling uphill or downhill on a highway, it experiences a force due to gravity This force, we're going to call F, is in pounds, is the grade resistance, and is modeled by this equation right here. F equals W sine of theta, where theta is the grade, that's what we call the grade, and W is the weight of the automobile, usually in pounds. And if the automobile is moving uphill, then our theta is going to be stated as something greater than 0. And if it is moving down here, our theta is going to be something less than 0, so a negative number. Okay, let's look at our questions. All right, so here are questions about what we were just looking at in the previous slide. It says calculate F to the nearest 10 pounds for a 5,500 pound car traveling uphill, an uphill grade with theta equaling 3.9 degrees. So we got all the information. We have the weight, that is our pounds here, that's the weight of the car, and we have our angle theta, that's this given right here. So just plug away into your formula, and then we're going to plug into our calculator. Now, when we plug that into our calculator, I have already gone and done that, we get approximately, let me write the correct symbol there, we get approximately, now it says round to the nearest 10 pounds is what that is stating. So I get 370 pounds. And that's 370 pounds of force due to gravity. Now, we're going to be asked here on part B to calculate F again to the nearest 10 pounds for a car that weighs this much traveling on a downhill grade with theta equal to negative 4.8 degrees. Again, we're given all of our information. So F equals our weight of our car times sine of our negative 4.8. Now in this example, or these examples, it tells you the upgrade hill with theta equaling 3.9. Now if it said an upgrade hill of 3.9 degrees, that our degrees is going to stay positive. And if you're given an example or a problem in your book that says traveling on a downgrade, a downgrade of 4.8 degrees, well, if it says downgrade, then you need to put a negative on your degrees whenever you are plugging it into this formula. Okay, so this, again, I already found that in my calculator, and that is negative 230 pounds. And that is true. You can get a negative force due to gravity, and that is what it's equal to. All right, last example, part C of this. So in part C, we are asked, it says a 2,400 pound car traveling uphill has a grade resistance of 288 pounds. What is the angle of the grade? Okay, so let's write down our force equals our weight times sine of our theta, which is the angle grade. That's what we're looking for, is what is this? And we are given that the grade resistance in pounds is 288. So plug that in for F. And the weight of the car is here. Plug that in for W. And now we have this equation we're solving for sine. We're going to be using inverse sine to help us in figuring out what theta is. All right, so before we go and take the inverse sine of either side of this equation, we need to divide. We need to get sine of theta by itself. So let's go ahead and say 288 divided by this is equal to sine of theta. And sine of theta, to get theta out of that sign, we must take the inverse sine of both sides. So we're going to say theta is equal to sine inverse of, we could reduce that fraction, but it doesn't really matter. We could plug it into our calculator all the same and get the same solution. Here it is. Plug that into your calculator. The inverse sine, or sine inverse of 208 over 2400. And it says, what is the angle grade? Well, I'm going to tell you, let's just approximate this angle again to 2 decimal places if your book doesn't state how many places to approximate to. And I went ahead and did that in my calculator. I got 6.89 degrees. And I think that is it. Yep, that is it on this section. So not too bad section. Just remember your reciprocal functions and stuff like that are going to be used in this section in order to help you figure out what you need to plug into your calculator. So I will see you all in class. Goodbye, everybody.